This video is going to be about the derivation of the wave speed equation. So before we get started, it's important to remind you that the wave speed equation describes the speed at which the wave's energy is moving or traveling, not the oscillation speed of the particles that make up the wave. So we'll start our derivation, which is thinking about our general speed equation. So we know that speed is equal to our displacement divided by the time it took us to be displaced that far. Okay? And so what we're going to do, we're going to say, okay, how far is it take for one wave to travel how far does one wave go when it completes one oscillation? And so the answer to that is one wavelength. So a wave goes one wavelength when it's completed one oscillation. Okay? And how long does it take to complete one oscillation? Well, we know from our definitions of our terminology for our waves that the amount of time it takes to complete one oscillation is the period of the wave. Say that's wavelength over period is equal to my wave speed. We could also say that we could also say that period is equal to 1 over frequency. So I could rewrite this as frequency is equal to 1 over period, and therefore my wave speed would also be equal to wavelength times frequency. So this is a really useful equation. It'll appear in your data books as the speed of the wave is equal to the wave's wavelength times its frequency. That's it. Before we finish up, I just wanted to talk really quickly about the factors that affect the speed at which a wave's energy travels. So it's important to note that only the media type determines how fast the wave speed travels, or affects how fast the wave's speed is. So this means that you can see that things like, for example, sound travels much, much faster in water than it does air. And when you try to do your slinky waves, you guys will see that the harder you shake the slinky, it doesn't make the wave travel any faster, because the slinky is the medium through which the wave is traveling, and it doesn't matter how hard or how fast you shake the wave is going to always have the same speed in the same media.